What's going on, guys? My name is Divyesh Jadwani, and welcome to my YouTube channel. So, guys, I'm super happy to tell you that from here onwards, we are starting off with a very important, a very hot topic of the agentic AI space, which is LLM evaluations. It is very important as part of LLM security as well because we want to ship all the production ready applications. Now, what do I mean by production ready? Those applications which do not hallucinate, those applications which are correct in terms of the user queries, and those applications which retrieve the correct information from the tools. Right. So, how do we do that? And what is the exact terminology or exact concept of understanding all of that? Is LLM evaluations. We are trying to see or we are trying to check how our LLM is going to perform in real world scenario is what LLM evaluation is all about. So let us quickly go ahead and understand about LLM evaluations. Now, what exactly is evaluation? Let us say you are a student and you are studying in a school. You have been trained for, let us say, 6 months. Every day you have been said that this is science, this is history, this is mathematics, this is geography. Every day you have been trained on all of these subjects. And finally, after 6 months, we need to make sure that are you ready to go towards the next grade? You are in sixth standard. We are trying to see are you ready to go in the seventh grade? Now, you will only be ready to go in seventh grade when you pass an examination. And this examination is nothing but your evaluation. We are trying to see that on the topics which you were trained for all of these months, are you now properly answering those questions? Now, for all these 6 months, we were giving you the question and we were also giving you the answer, right? But what is going to happen in exam? You are only going to be given a question and you will be writing the answers will not be provided, and these answers will be checked by your teacher with respect to the actual answers, right? So what is going to happen with this? We are trying to measure the difference between the predictions and the actual reality. Actual reality here refers to the actual original correct answers which are given in the form of answer sheet or you know marking sheet or marking schema to the teachers that for this particular answer for these keywords you will give this many marks. And prediction can be referred to as the answer sheet which students write in their examination, right? So a student is only promoted from a junior school to a high school when he's passing any exam, right? Similarly, a candidate is only taken into job if he is passing an exam. So what is this? What are we trying to do over here? We are just trying to make sure that whatever the large language model was trained on top of, it is doing its job correctly before going into the production stage. What is production stage? Right, it is as good as the student passing from a university and going for a job. He's ready for a job, right? Now he will be only ready for a job if he has passed his examinations. He will not be ready for the job until the examinations are not passed, right? So this is LLM evaluations. If I just go ahead and simply define it, LLM evaluations, let us see. LLM evaluations are the tests used to check if an AI model, likely a chatbot or a writing assistant, is doing its job well, safely, and accurately. Right? We have trained an AI agent for HR policy. We want to make sure that every question which we ask, he will search the database for that, which means he will use a tool no matter what, and always he will answer questions only related to policies, right? Because the task is for a policy assistant, right? This is the whole purpose of evaluations, to make sure if the LLM is performing the job properly. Now, how are these evaluations done? We can talk about the most kind of use cases. The first one, the first concept of evaluating these large language models, and of course, just how in exams we give them a score that, out of 100 marks, you scored 80 marks. Similarly, we also assign scores to our large language model in terms of marks. All right, these marks are usually in between 0 to 1, and many of metrics are considered. So let us talk about that and how it is done. Multiple ways are there to evaluate our large language model. One of the way is a very famous way and the most used way, LLM as a judge. What does this mean? Here, the model which is used, in production, let us say it's a small model, 8 billion parameter model, and there will be another large language model which will be a slightly bigger model than this, let us say 60 billion parameter model. This model is enabled with reasoning, which means it can do deep research and everything. Now, bigger models are usually better models, a smarter brain, a bigger brain, right? So we always try to use a better model to evaluate the model which is being used in the production. So the LLM will be evaluated by another LLM itself. This is called as the concept of LLM as a judge. All right, where a bigger large language model will be utilized. Let us talk about the second kind of scenario. This will be human evaluation. Human evaluation is where, a human will literally sit and see what are the responses produced by a large language model. All right. The third way is rule based way. Rule based, where we just simply check if is this model given by large language model is equal to the model which we have taken as a reference. All right, everything will make sense. Everything will make sense in one more minute when we will see the demonstration. And there is also one more way where we calculate the statistical metrics. All right, we don't have to go in all of these depth at this particular point of time. For now, let us understand there are two basic ways or two major ways. Either LLM as a judge, which means we will use another large language model to judge our production large language model, or we will use a human evaluator. Now, human evaluator is a very costly process where you will pay a human to check your large language model, subject matter expertise. And LLM as a judge is a cheaper solution when compared to human evaluator, but the process of entire evaluation itself is very costly. We will understand why and how. All right. So let us go ahead and see a demonstration right here, which I have prepared for you. Now check this out. And let us also understand the use case. So use case is we have developed a chatbot. This chatbot is being trained, or this chatbot is enabled with a database of customer queries. Customer queries, right? This is a customer chatbot, e-commerce customer chatbot. And the database contains various kind of queries. The database contains policies. The database contains product information, which means what are the products available into our website. And thirdly, it also has FAQs, frequently asked questions. So how it is going to work is we will have a website, let us say Amazon. And on Amazon, we have different products, right? In the corner, we will have a chatbot right here. And we can interact with this chatbot that suggests me some jeans, suggests me some grooming material, suggests me some body wash, okay? Anything we can ask to this chatbot and this chatbot will retrieve that. We can also ask, do we have a return policy, right? And frequently asked questions. All of these questions, a database is made of all of these and it is given to the chatbot. Let us go ahead and look at this database now. Check this out. I will clear out everything and one by one I will add all these informations. And this link will be provided to you. So first, let us see the product information. This is a product ID, just how we have roll number for students. The name of the organization is TechNest. Category is product. ProBook L1 laptop, Pixel phone 15, SoundPods Pro. Okay, so just some random products, Smartwatch X. And this is the description of that. Okay, these are the descriptions of those products. TechNext X1 book is 14-inch laptop, Intel Core. So product information is given. We need to give product information so that our chatbot can perform answers on that. TextNest smartwatch features continuous heart rate monitoring, SpO2 tracking, GPS tracking, all of these things, right? So we can see product information. Let us add another kind of information. Another information is policy information. Now see, we have added policies: return policy, shipping policy, warranty policy, and payment policy. And it will have TechNest have a minimum 1 year manufacturer warranty covering defects in material, workmanship, etc. You can read all that. Lastly, we have FAQs. So FAQs regarding order tracking, internal shipments, bulk and businesses. So to track your order, visit this particular website. So this is a scenario where we are properly thinking that how we will develop a chatbot, right? This is the kind of data and this is the kind of chatbot we are making. Now, what is the goal of this particular data set? All right. The goal of this particular data set is to be given to a large language model. This all these all will be used by our large language model to give response. For example, so this is soundbar, right? I can just simply ask my chatbot that tell me if I what are the ratings for soundbar 360. Tell me the features of soundbar 360. It will tell that 120-volt output, subwoofer, Dolby Atmos, right? This is the whole purpose of having this database, right? Now what we want to do, we want to, so our RAG is already developed. Our RAG system is already developed. We are not going to talk about the development of RAG. We have already made a RAG where there will be a user which will pass our questions to our large language model. This large language model will be connected to a database, and this is the same database which we just saw. And looking at this database, it will answer all the user questions, and this will give back to the user the response. All right, this is the entire cycle which is already made. Now we want to check if this cycle is working correctly or not, which means for a given question or for every question, is it really answering from the database or is it generating with its own thoughts? Because large language models are tricky in nature, random in nature. So is it using the database to answer the questions, right? If the question was asked, tell me about Soundbuds Pro. The question was this, and the large language model is telling both speakers are really good. Okay, this is not correct. Even though it got the data information from the database, but the response it is giving that I asked about soundbuds, but you are replying about both speakers. This is not correct. The answer is not relevant to the question. All right. So we want to check all these kind of things before before we are shipping our large language model to production. We cannot ship it until we are 100% sure that always our large language model will do good. All right. So this is the entire use case. And now we are going to go ahead and start to talk about the different terminologies involved and when understanding large language model evaluations. When we talk about different terminologies, which means we have to learn a few terms, we have to understand a few small definitions that what are these things in order to understand the LLM evaluation process altogether. So we have something called as Goldens. Okay, now what is Goldens? If I say Goldens in simple word, this is a question of a question paper. Okay, a question of entire question paper. What is dataset? Dataset is the question paper itself. And thirdly, we have evaluation matrix. Evaluation matrix is nothing but answer sheet provided to your teacher to check the answer. So answer schema, which means which answer should get how many marks. All right. So let us understand Goldens and what all things it contains. So a Goldens is a single unit of evaluation. Okay. Goldens, let me write it down. Single unit of evaluation. A golden is also called as a test case, and a golden is also used as a single unit, one of the unit of the evaluation. So what all things this golden can contain? This golden will contain the question, that what is exactly the question. this golden will contain what exactly is the response expected, which means the answer question. What will exactly be the answer of this question, which means the answer sheet which is provided to the teacher. And thirdly, it will contain a response which is actually given by our large language model. All right. And there will be more things. All right. Let us elaborate this and understand this better. We are talking about a golden. Okay. Golden is nothing but a test case. And in simple word, one question of a question paper. Now, in a golden, there will be multiple things. First will be what is the original question. For example, tell me about soundbuds. Tell me about AirPods. Okay. AirPods. This is the question. Then there will be an actual answer, real answer. Okay. I'm calling it our answer, real answer. Here it will be written AirPods is by Apple for some XYZ dollars. All right. Then there will be, expected tool usage, which means every time our large language model is going to give this response, it will use this particular tool. I mean, it should use this particular tool. So in our case, it should use the database tool. And then we will have actual answer. So A answer, this is the answer when LLM is giving the test and it gave this answer. And then we will have actual tool use. For example, in our case, the LLM did not use database tool, it used web search tool. So negative markings for this. And if answer is AirPods, and if answer is tell me about AirPods Pro price, okay, and the answer is AirPods Pro price is XYZ dollars. So in this particular scenario, the answer was correct, but the tool which was used was incorrect. All right. So plus marks for answer and negative marks for the tool usage. All right. These are, this is called a golden. And when we combine multiple goldens, all right, multiple goldens, this is one golden, second golden, third golden, fourth golden. When we combine multiple goldens, this becomes a data set. All right, let us go ahead and literally see the golden which we are going to use in our case. All right, this link will also be shared. I'm going to go here. Okay. And let us check out this goldens. All right, let us check out this golden. This is the each entry. We have a product title and the content. This is the each entry. And this is the kind of golden. This is the golden. We have to focus on a specific metric. We will talk about that later. This is what is TechNest return policy. Returns accepted within 13 days, original packing, something like this. All right. So we are making different goldens. Let me just check if I have a better goldens example for you so that you will be, yes, check this out. User input, do you offer return shipping? Now we also have one more metric. I will talk about that later, where we are talking about what information was extracted from the database. So this means that, all right, your RAG or your LLM was should have used the database, but did it get the correct information from the database? It used the database, no problem. But was correct information extracted from the database? So that is nothing but retrieved context. Was that correct? Okay. This is the response which our large language model gives. Yes, we provide free prepaid return. But the reference, the actual thing was no, customers pay return unless item is defective. So here negative markings will be given, where actually the chatbot should have said no, customers pay return shipping only if the item is defective. But instead of this, chatbot said yes, we give free prepaid returns. This is not correct, right? So similarly, we create multiple goldens in this particular way to evaluate our large language model. And multiple goldens is a data set. And what happens is we pass this entire data set to our large language model. So let me show you the data set which we have prepared. And Dataset preparation in LLM evaluation phase is the most time consuming phase. If we have 1 hour to evaluate our large language model, we will spend 55 minutes in preparing the data set, and we will spend 5 minutes in actually testing our data set. All right. So that is how important dataset preparation is. Datasets are usually prepared by subject matter expertise or either by a large language model itself. We will talk about that as well. Then let me show you this particular thing. These are our goldens. Goldens, check this out. We have prepared a few goldens. So we have prepared only 5 goldens. What is tech nest return policy? We are trying to focus on a specific metrics. We will talk about it. The name if is faithfulness. We will just study about it in some 5 minutes. The answer should be TechNest accepts returns within 30 days of purchase items, must be original in packaging all accessories. Customers pay return shipping unless the item is defective. So this is the question and this should be the answer. Similarly, this is the question, this should be answer. And the same for all. How long is the battery life of SoundPods Pro? 8 hours of battery life, all of these things. Okay, question answer is given. We just want to make sure if our large language model is doing or not. The pipeline runs in 2 phases. First, each of the golden, okay, each of these goldens, which means each of the question paper is solved by the student. Similarly, in the phase 1, each of the question is passed to our large language model, which means to this system which we have made. Okay. Now, these are the responses. These were the question paper. This was the question paper and this is the answer sheet generated by large language model. So see, what is TechNest return policy? The answer is TechNest return policy returns 30 days of original purchase date, etc., etc. And the reference answer is TechNest accepts 30 days of purchase, which means these both are matching. The thing which we were expecting that it should say 30 days and it really said 30 days, which means this test is passed. Okay. Similarly, we can see another test. How long is the battery life? So for battery life, it should say 8 hours. It did say 8 hours and we were also expecting 8 hours. So it has passed in these cases. And once the entire question paper is solved, okay, we go for phase 2 where we calculate all the metrics. Okay. In phase 2, we are also checking the metrics. Yes, we are checking the metrics. And after the entire question paper is checked, we are getting some results. Okay, we are getting some results in this way for each of the golden. So each answer gets some marks and these marks is what we are going to proceed with. All right. See, per golden detail. So how it is written? This was the RAG response. This was the information retrieved from the database. And this is what we were expecting. Similarly, this was the question. This was the RAG response. This is the retrieved information from the database. And this is what we were expecting. And we try to match both of these and this and a lot of things, right? So these are evaluation metrics, the marks given to the question paper. All right. And this was all about understanding the terminologies of evaluation processes. All right, people, now that you know what are LLM evaluations, why we need LLM evaluations, all those tricky terminologies that occur while evaluating your large language models, we have got you covered already, right? Now let us go ahead and start talking about the different metrics involved in evaluating your large language model. Just how if we talk about deep learning or machine learning, in those we have different metrics like accuracy, precision, recall, right? So those are metrics to evaluate your ML or DL systems. Now we are talking about evaluating our large language models. So multiple different metrics come into the picture, right? A different test will be taken. For example, you are going for military training and you are going for pilot training, right? Two different kind of tests will happen in both the scenarios, right? So that is the whole purpose, that with the domain shift, the evaluation metrics will also shift. right? So let us go ahead and understand all those tricky and all those interesting concepts. So now we will talk about the evaluation metrics. What are these evaluation metrics? Evaluation metrics are the scores given to our large language model for its performance, how it performed on real world data, how it exactly, how are we going to grade it, the grading marks of our large language model for solving that question paper. Now what are these different metrics? I'm just going to write all of them down. Let us first understand all the names. So the first particular metric is called faithfulness. Okay. And instead of writing all the metrics, let us understand each of them one by one. Now, faithfulness. To understand faithfulness, there is an important topic which we have to understand is hallucination. Okay. Hallucination. First, let us understand the Google meaning of it, and then we will talk about our definition of it. Okay. So I'm just going to go here. Okay. What is LLM hallucination? Okay. Let us understand this word. We all are familiar with this word, but let us understand. LLM hallucination occurs when model confidently generates information that is incorrect, completely fabricated and unsupported by the training data while it's presenting its absolute truth. All right. Now check this out. The question was, the user gave a question that tell me about Soundbuds Pro charging battery life. Here, this question went to the large language model. The large language model successfully went to the database to get the information. And the database also gave the information that Soundbud Pro gives 8 hours and etc. etc. But now, given all this information, LLM should have responded to the user that yes, 8 hours of battery life. But what LLM did is, LLM gave the response that Soundbuds Pro are not the best buds which you should go for, and the battery life is only 2 hours. I will not recommend to buy this buds. All right. So what did LLM do? LLM hallucinated over here. All right. Even though correct information was given, even though everything was going absolutely correct, but in the end, when it was the time to show the performance or do the complete the task, at this time, due to some wrong technical error or due to the model not being engineered properly, the LLM gave a wrong response. That is called as LLM hallucination. And we are checking LLM hallucination with the metric of faithfulness. Faithfulness will measure the amounts of hallucination of a chatbot. That how much did our chatbot hallucinate? One last time, hallucination happens when even though correct information was passed using a tool to the large language model, then also large language model gave a wrong response. This is hallucination, and to measure hallucination we use faithfulness, and the marks are between 0 to 1. 0 being the highest hallucinated, very high hallucinations, and 1 being to the lowest hallucinations. All right, and if we check the score of our question, here is our database. For our first question, the hallucination level, I mean the faithfulness, is LLM faithful to us, which means when we give the correct information to the LLM, is it faithfully giving us the correct information too? All right. Is the LLM faithful to the user? Okay. So this is faithfulness. In our case, we have received 1 on our score, which means our model is very faithful. All right. So see, for each question, five things are checked. All right. So this is faithfulness. The next metric to evaluate our large language model is answer relevancy. Answer relevancy. So answer relevancy is a simple process where we see, is the answer given by our large language model relevant to the question which was asked. Okay. This is how simple it is. if the question was asked regarding soundbuds charging, the response should be regarding soundbuds charging. That is it. This is called answer relevancy, which is the second metric, where it will simply measure was the answer relevant to the question which was being asked by the user. And this is answer relevancy. Let us check the answer relevancy for our question. So here as well, what is TechNest return policy? TechNest return policy, the answer is TechNest return policy. All right, the question was regarding TechNest return policy, and the answer is literally regarding the return policy, right? And it will not check if it is relevant. I mean, if it is correct or not. It will only check if the answer is relevant to the question or not. To check the correctness, we have another metric. Here, it will only check the question was asked regarding return policy. Is the answer also regarding the return policy? Only this much. All right. So for specific small components, we have many metrics. So let us understand the next metrics, and then things will be really clear. All right. So let us understand the third kind of metrics. The third kind of metrics is really simple. Tool correctness. Okay. Tool correctness. This is not what I have used for demonstration, but this is very important, and I will also explain why I have not used it for demonstration. Now, tool correctness is only the process of checking if correct tool use was used or not. Checking correct tool usage. When we ask our AI to search for latest news, we expect it to use web search. When we ask our AI to research, then we expect it to use a research tool. And when we expect our AI to answer from the database, we expect it to use the database tool. Always, right? So this is the process of checking tool correctness, if the tool which is being used is correct or not. This is the cheapest metric, where we will just simply see which was the tool used by our large language model, and we will just simply write a Python line of code if the tool used by AI was exactly equal to the tool expected. As simple as that. And this is what is tool correctness. As simple as that, right? Let us understand the fourth kind of metric. We have not used, if you were wondering why have we not used tool correctness, because in our case each question will be always answered from our database. All right, here in the scenario which I am demonstrating, I have not made an agentic process, okay, where a LLM will think. Okay, agentic process is where a LLM is trying to behave in a certain way. Here LLM will think, should I use the database and answer the question, or should I directly answer the question? This agentic process is not what I have made over here. I have made a chain process over here, and I have used LangChain, not LangGraph. If I want to make an agentic process, I will use LangGraph. But I have used a chain process where when user is giving a question, it will by default be sent to our database, and the context will be passed to large language model, and then the model will give us the response. I've used a chaining concept in here. That is why I have not used tool correctness, because there is no concept of tool over here. It is already a part of our RAG system, right? And when we want to develop, we can develop these systems, right? It is our choice of engineering that if we are developing an agentic process or if we are developing a chain process. So that was about tool correctness. Let us talk about the fourth kind of metric. Very interesting metric. And the fourth and the fifth kind, I will have to write it together because it is important. Here we have, okay, instead of answer, we will write context. So the name of this matrix is context precision. And the name of the other matrix is called as context recall. Okay, context precision and context recall. We all know when a user is trying to ask a question to the large language model and the large language model is trying to get some information from the database, when the information is given from the large language model to the database, it is given in terms of retrieved chunks. Okay, because in the data ingestion process, if this was the entire data, we break it down into small parts. All right, so when database is passing this kind of information to the large language model, the database is also passing small chunks to the large language model to give the response. Let us check that out. So when if we see this, everywhere it has received some chunks, chunk 1, chunk 2, chunk 3. All right, now if I talk about the metrics, if I just quickly talk about both of these metrics, should be here. 1 second, I'm just scrolling it down. Should be here, and this will also be provided to you. We have two things: context precision and context recall. Context precision is when retrieved chunks are mostly relevant, and context recall means fetched all chunks answer the needs. Let me explain that to you one by one. Now we understand that when LLM is asking something to the database is giving some responses. Database is passing some retrieved information like this. Okay, let me write it down properly. All right, and this is it. I'm just writing that database is giving these all information. This is about the sound quality, this is about the charging, and this is about the life of the soundbuds pro. If let us say the question was about soundbuds and the database has given the information about soundbuds, the question was regarding the charging, okay, of soundbuds pro, but the database searched specifically for soundbuds because it is a statistical searching. Okay, it is not LLM searching, it is statistical searching. So database literally searched for soundbuds pro, where in the information it will find out what is the charging, what is the life and everything. But the question was what is the charging of soundbuds pro, and the information database has given is this is the charging of soundbuds pro, this is the quality of the buds, and this is the life of the buds. Three different kinds of questions are answered. Let us say the first response was regarding the sound quality. Let us say the second was regarding the charging. Okay, let us say one was regarding the life and the third one was regarding the charging. Here we want that, see, the question is regarding charging. So obviously the charging one should be the first one, and then these should be the second and the third one. They should be re-ranked, okay? Rearranged or re-ranked. The documents which are fetched from our database, they should be reordered properly. All right, where charging should be the first, life and quality should be the second ones. All right, and this concept of re-ranking, where the order of the context is properly ranked or not, is called as context precision. If we are fetching the information in the right order, this is the concept of context precision. And second one is context recall. This is very simple. This metric will only make sure if the question was regarding charging, have we retrieved the charging kind of data? Now, whether it is on third, fifth, eighth, doesn't matter. It will only check, are we extracting the correct information? And this will check, are we extracting the information in the correct order? Okay, this is context precision and this is context recall. Both of them are really different. All right, this is for correct order and this is for correct information. Let us talk about the last metric. The last metric is called as answer correctness. Okay, answer correctness. Let us go ahead and first read about answer correctness so that we are not confused anywhere. All right, let me go here and let us talk about answer correctness. should be here itself. All right. And I will share this link with you, like I've mentioned. Answer correctness.
Can you send everything through email or the link through email?
I will.
Okay, no worries. Thank you.
Yes. Check this out. Answer correctness is if the LLM answer matches to the ground truth reference. Okay. As simple as that. So answer correctness is if the output given by our large language model is correct. Okay. As similar to this. Okay. What do I really mean? Is it matching the ground truth reference? What do I really mean? That we created some goldens. In this goldens, we had a question and an expected answer. And then we have the actual answer. In the process of answer correctness, we will compare both of these. Is the expected answer and the actual answer correct? In the terms of answer relevancy, we were checking is the response which is given is relevant to the user question. Are they matching? Okay. But answer correctness will check the answer which we were expecting and the answer which we have received is similar or not. Yeah. These were the different metrics. And let us revise all these metrics. First metric was faithfulness. Faithfulness will check if the LLM model is hallucinating or not. If the database information which was received by the large language model, did it also use that information to give the response? Second one is answer relevancy. Answer relevancy means, does the answer match the user question? Is the answer relevancy. Third one is answer correctness. Answer correctness is the process of checking if the answer is matching with the answer we were expecting. All right. Answer we were expecting. Then after answer correctness, we have tool correctness. Tool correctness is the process of checking did the LLM use the correct tool or not. Correct tool or not. Or we can also say that did the LLM, the tool which LLM was used, was it equal to the tool which we expected? So both of these correctness are same. Answer correctness means is the expected answer and the actual answer matching. Tool correctness means is the expected tool and the actual tool matching. Then we have context precision and context recall. Context recall is the process that the information which we got, did we get in the right order? And context precision means the information which we got, is it correct? I mean the information which we got from our database or from our web search tool or from our researcher, is it matching to the results which we were expecting for respective question? All right, people, wasn't that so simple? All those tricky concepts, all those weird words, all of that in so simple language, right? Now we are done with understanding LLM evaluations. Let us proceed ahead and understand the different frameworks, the technologies which you can use to evaluate your large language model. So now we will go ahead and talk about the different evaluation frameworks, the different technologies which we use to evaluate our large language models. All right. So the different evaluation frameworks are as follows. The very first is Langsmith. This is also observability tool, but this is also a evaluation tool. All right. In Langsmith, Langsmith is a part of LangChain ecosystem where we can either evaluate our LangChain or LangGraph based systems. LangChain is where we make chain kind of systems, and LangGraph is when we make agentic kind of systems. And when we want to evaluate these systems within the LangChain ecosystem, we go for Langsmith. Langsmith provides us a way of creating data sets and experiments. Now, in this case, we can either use Langsmith only to make our Goldens. That is also a facility provided. We will check that out. So we can just simply go to the Google and we can just simply check out Langsmith evaluation. We will have a direct doc over here. We can open it. And on Langsmith evaluation, you will be able to understand that how can you create a data set, with samples. We will do this in the upcoming projects. But for now, this is the documentation which we can go through. We can also go to the GitHub, right? And here on the GitHub, we can check if there is something regarding evaluations. All right, there is nothing regarding evaluation. So I think it will be regarding, Langsmith itself. Langsmith docs. We can check the stars and the forks, and the active development is 4 hours ago, right? The next one we have is RAGAS. RAGAS. The framework which I have used in this particular demonstration, if I was to show you, this particular demonstration which I have used is RAGAS. All right. Why have I used RAGAS? So RAGAS is the evaluation framework for specifically evaluating RAG based applications. All right, dedicatedly make to evaluate RAG based application RAGAS. Every time you have made a RAG application, you will use RAGAS to evaluate. So let us go ahead and check out RAGAS. Check out RAGAS evaluation. And the first framework which we can see is RAGAS. See, let us check out RAGAS. See, introduction. RAGAS is a library that helps you move from vibe checks to systematic evaluation loops for your LLM AI applications. All right. We can also go to GitHub and see the community. 14.6k stars 4 months ago. So it was in active development. Now it is stabilized. So that is why there is no development over here. 1.5 folks. Why RAGAS? What are the key features of RAGAS? How to get started? What are the core concepts? If I go to core concepts, we can go to RAGAS metrics and see. Here we will see all the metrics. Let us see. Are we able to get them? Answer correctness. There is more things. Citation accuracy, retrieval accuracy, right? So different domains have different things. Business metrics, which means ticket deflection rate. You can read about all of these interesting concepts, right? LLM based metrics, non LLM based metrics, singleton metrics. Singleton metrics is a single sample. All right. Discrete metrics. There is n number of things. You can just simply go ahead and read them. Factual correctness, right? So many unique different terms coming into the picture, right? So this is RAGAS, and do check it out. The third kind of framework which we have is called deep evals. Deep evals. Now, deep evals is used when you want to evaluate your agentic systems. Deep evals will help you to check your tool correctness. Deep evals will help you to check what exactly information is being communicated within one agent, what conversation is happening between one agent and another agent. All these things deep evals will help you to check. Let us go and check deep evals. I will go and check deep evals. Deep eval, the LLM evaluation framework. Let us go in here. And this is developed by Confident AI. See, This also has 16.5k stars, and this has 14.6k stars, Raga. So you can compare like that. The development was 2 days ago, so they are actively developing. We can understand that. And if I open Deep Evals developed by Confident AI. The organization who has developed is Confident AI. And we can just simply get started by going to the docs. And we can also understand integrations. Integrations means the partners of Deep Evals. So see, LangChain, Pydantic AI, OpenAI, LangGraph, Strands, Llama Index, Anthropic, Crew AI. These are all the partners of Deep Evals, which means Deep Evals can be used with all of these. Okay. If my question is, can we use Agno with Deep Evals? So the answer is yes, but Deep Eval is not a partner of Agno. Okay. Or AutoGen. We remember AutoGen by Microsoft. Right? This is for making AI agents. Right? This is it. AutoGen is not a partner of Deep Evals. So evaluating our application using Deep Evals, AutoGen application using Deep Evals will be a little bit tougher because we cannot directly integrate it. Okay, but we can write some codes which, everything is possible, only it will take little bit efforts. So if they are already partnered, which means we can trust them to use it and we can use it in our systems. Google ADK is also one of the agentic frameworks. I can open it. Okay, I've never mentioned this, but Google ADK is also just like LangGraph, LangChain. This is Google ADK. Very, very interesting and very complicated framework this is, in my eyes. It is not simple to use. People who do not understand software engineering, they won't be able to use Google ADK. But you can definitely start with it. It is the most mature framework ever. Most mature framework, Google ADK. All right. So this is Deep Eval. This is the docs. You can compare. See, comparisons it has given. It has given comparisons with different frameworks, observability platforms, right? And it has also given comparisons with all these different agent first evals is also a framework, fast local loop, PyTest and CI/CD. So you can compare all of these things as well. You can read and you will understand. Design philosophy, how this particular deep eval system is designed. Trace aware, which means we can trace the execution. All right, test cases, data sets, metrics. Let us check out metrics. See, in metrics we will have different metrics. For example, answer relevancy metrics. See, and as you go ahead, you will find many much more metrics which we discussed, right? Answer relevancy and custom metrics, generic metrics, lot of metrics. When you read it, you will understand. See, they have also given beautiful diagrams and everything. Faithfulness metrics, tool correctness metrics, conversation completeness, which means the conversation which is happening, was the conversation completed by the chatbot, right? So many different metrics you can always explore, right? And the fourth and the last one is pydantic log fire. Okay, this is also observability tool, but this is also used for evaluation. Let me show that to you. So pydantic log fire evaluation. This is exactly similar to, not exactly, but this is similar to your Langsmith. Just how Langsmith provides for LangChain and LangGraph, Pydantic Logfire provides for Pydantic AI and Pydantic. Okay. See, AI and observability LLMs for agents. We can go to docs. We can go to Logfire. And in this Logfire, we can go to evaluate. Check this out. Evaluate. Here we can make data sets and experiments. We can make different list of the data sets. See, last run, experiments, cases. There is much more in the database, right? Schema and lot of things. So you can explore and you can read about it. Let us see live monitoring. What is live monitoring, right? So different things you can explore. And that was all about the different evaluation frameworks which we use to evaluate our large language models or agentic systems. So now now what we are understanding is I'm giving you this application in the link, and you can test your RAG application. All right, you can evaluate your RAG application yourself, in which there is some data already. There is a list of Gordons. You can run your evaluations. Now you cannot run your evaluations until you have Groq and API key. In here, the concept which we have used is judge LLM as a judge. In this scenario, you are supposed to use two different Groq keys, which means you will use two different email IDs. On one email ID, you will create a Groq account and get the Groq API key. Let me show you how. Groq API key. You will go here and you will create an account on Groq, and using Groq, you will get an API key to run your LLM application. You can use this key, you can give it some name, and a key will be generated. Okay, see, a key will be generated. And once this key is generated, you are supposed to go on another Google account and follow the same process. And when you are onto this app, the app is here, you are supposed to add one account key over here and this another account key over here, judge Groq. This is going to judge your large language model, the execution. Third one you need is Gemini API key. So for Gemini API key, you have to go to Google AI Studios. When you go to Google AI Studio, okay, this is not permitted in this account, but I can just go to some another account. Let me pull this. I will just search Google AI Studio. See, I can also give this link to you guys. Google AI Studio. Here you can again create your API key, give it a name, create a key, and you can create a key. All right, and that key you will paste over here. So you will get some key like this. You will go here, and once you paste your key, let me see, where is it? Once you paste your key over here, you will have Goldens ready. This is your data set ready, on top of which your RAG application is made. This is the question paper of your RAG application, and this is the evaluation. You will run the phase 1 of asking the RAG to solve the question paper, and see, once the RAG has solved the question paper, okay, once the RAG is solving the question paper, then you can check the question paper, which will be the phase 2. Now phase 2 will be time consuming. It will take a lot of time to evaluate. For example, paper checking takes time, right? So you have to run it. You don't have to close the tab. You have to wait for 15 to 20 minutes. You can watch the execution one by one. Each of the metrics will be calculated. See, you can run the phase 2 from here. Okay, I can restore the checkpoint, which means I had already run this before, right? I can either restore it, and once I have run the phase 2, okay, I will be able to see the results over here. It will take 15 to 20 minutes. We can see context recall in the last question was not so good. Okay, but the last question was written to check answer correctness, and answer correctness is good. Okay, so you can properly understand how this is made, and evaluations will be extremely clear. And you can also download results.json, wherein you can check in the results, that how results were generated in the JSON format, right? And that was it, people. Now you absolutely know what are LLM evaluations and why do we need them and which technologies you will use when, right? Wasn't that all you needed to understand this particular concept? So I hope you really enjoyed this particular video. All the links which are covered will be provided in the description, and I hope to see you in the future videos. Until then, stay happy, live your life. Bye bye.